All right, this is lesson 523. We're going to learn how to multiply binomials that involve addition. We're going to use the distributive property now. We're going to use the rectangle diagrams just to make sure we're doing it correctly, because we're familiar with that from the last lesson. But remember, the distributive property in a simple form is this. You have something multiplied by something in the parentheses. You have to multiply that by each of those things in the parentheses. So those are equal. And that's the idea that we're going to use here. So, and we have two things in parentheses. So to start out, we're going to take this x plus 3, and we're going to multiply that by each of those things in the parentheses. In other words, we're going to multiply it by this x and also by this 4. And that's going to look like this. X plus 3 times x plus, and then x plus 3 times 4. So I multiplied this x plus 3 right there times this first thing in there. There it is. Then I multiply x plus 3 again by the second thing in there, the 4. And that's right here. All right, and now we're going to simplify that using the distributive property once again. So, got to multiply x times x, and that's x squared. Got to multiply 3 times x, and that's 3x. We have to multiply x times 4, and that's 4x. And we have to multiply 3 times 4, and that's 12. Then if I simplify that, I get x squared plus 7x plus 12. Now, I'm just going to draw a rectangle diagram to check that. And so if we have one dimension that's x plus 3, I'll just put a little line there. There's x plus 3. The other dimension is x plus 4, like so. Then this area is x squared. This area is 3x. This area is 4x. And this area is 12. And if you look back at my expansion, I end up with the same thing. So we did that quickly. All right, let's try another one of those. This one, the power of 2 is used to represent that we're multiplying k plus 5 times itself. So I'm going to write that in expanded form, and then I'm going to use the distributive property to expand that. Again, we want to multiply k plus 5 times the first term k, and k plus 5 times the second term 5. So that looks like this, k plus 5 times k, and then k plus 5 times 5. Now expand each of those using the distributive property, and I get k squared plus 5k plus 5k plus 25. And the second expansion was there, multiplying k times that, that's that. K times 5, that's that. 5 times k, that's that. 5 times 5, right there. Now simplify it. K squared plus 5k and 5k make 10k. And then plus 25. Now my little rectangular drawing that represents what I did, both dimensions are exactly the same, so it's, the whole thing is really a square. And so I have k plus 5 on both, and this part again is k squared. This little part down here is 5 by 5, which is 25. And this area here is 5k, and this area is 5k. All right. So number 3. We're going to expand. We'll take x plus a times x, and then x plus a times b. So that looks like this, x plus a times x, and then x plus a times b. And to expand that out, we are going to multiply that times that, and that times that, that times that, and that times that. And so we get x squared plus ax plus xb, or I like to put it in alphabetical order, bx plus ab. And I'm not going to simplify those because I don't know what a and b is, so I'm just going to leave it like that. But then my rectangle would look like this. For one dimension, we would have an x and an a. For the other dimension, an x and a b. And inside, we'd have x squared. Here we would have ax. Here we would have bx. And down here we would have a times b. All right. Let's do one more. So let's take this 2x plus 1 times 3x, and then 2x plus 1 times 2. And expand each of those using the distributive property. This times this, and this times this. So 2x times 3x. I am going to write that as 2 times 3 is 6, x times x is x second, plus 3x times 1 is 3x, plus, now we need to distribute this, 2x times 2 is 4x, and 1 times 2 is 2. And I can simplify 6x squared plus 7x plus 2. And my rectangular drawing can be a little bit different here. Okay, because we need 2x on one dimension. So I'll do that, plus 1 more. And then the other dimension, we need 3x plus 2 more. So that would look like this. And then if I added all that up, so this is x squared, and so is this, and this, and this, and this, and this. So that makes 6x squared, which makes sense. And then 7x, well, right here we have 2x and 2x. And here we have x times 1 is x. And if I add 2, 2, 1, 1, and 1, I get 7x. And then this little part is just 2 times 1, which is 2. All right. This next one says complete the table by substituting values for x into this equation. You can do this if you want, but I think we're going to save this for class, and I'll work with you on this in class. So let's move on to here. It says find each of the following products. To do that, we just need to multiply 7x times 2x, which is 14x squared, and 7x times 4, which is 28x. Now the second one, we need to multiply a binomial times a monomial there for the first. So we need to do 7x plus 3 times 2x plus, and then we need to do the first binomial times the second part of that. So 7x plus 3 times 4. And now I'm going to simplify that by expanding that and expanding that using the distributive property. So I get 14x squared plus 6x for the first part. That's right here. 2x times 7x and 2x times 3. And then the second part, I get 4 times 7x, which is 28x. And 4 times 3, which is 12. Now I can combine those and make it 14x squared plus 34x plus 12. And it says, how is multiplying a monomial by a binomial like multiplying a binomial by a binomial? How is it different? Well, it's the same because in both we use the distributive property. And it's different because when you are doing a binomial times binomial, you need to use the distributive property twice. So when you do this, you use the distributive property twice. All right? I'm going to do one more that comes from your homework problem. And that is, if you turn to page 8 and look at sorry, I told you the wrong page. Look at page 11, number 42. So go to page 11 now, 42. It says expand a trinomial and a binomial. I thought I'd do one of these with you. But it's really the same idea, just that we have one more multiplication when we do this. So, and what I'm thinking here is, so we're using the distributive property. And I'm going to use this as the thing I multiply by each of the terms in the trinomial. So I'm going to take x plus 1 times x plus 1 times y, and x plus 1 times 1. And that's going to look like this. X plus 1 times x plus 1 times y, and I can do x plus 1 times 1. And if I do that, I get, now I'm doing smaller distributive property, x squared plus 1x plus x times y plus 1y plus, and 1 times any number is just the number itself, so we just get x plus 1. And then I combine like terms, I have an x there and an x there, so I get x squared plus 2x plus xy plus y plus 1. So there wasn't a whole lot of simplifying there that I could do. All right. That problem could also be done, we could have distributed it another way, and I'll just show you that here. What if we would have taken our original expression, x plus y plus 1, and instead of distributing this 3 times, how about if we distribute this twice, multiplying it by x the first time, and then multiplying it by 1 the second time? That would look like this, x plus y plus 1 times x, here we go here, and then x plus y plus 1, the second part, times 1. And so now I need to do x times x, y times x, 1 times x, and in the second one, those are all multiplied by 1, so you can multiply by 1, it remains the same, and I end up with the same thing, but maybe a little faster this way, I don't know. So we can combine those two, and that's about it. And we'll work on this some more tomorrow.